In programming, data is like a very important message. We pass this message around different parts of our code. Each part might read it or try to change it. But what happens if a part of our program changes the data by mistake? This can cause unexpected problems, often called bugs. These bugs can be very hard to find. They hide in the code and make our applications behave in strange ways. Protecting our data means we are making our code safer and more predictable. It is a fundamental step toward writing software that is reliable and easier to maintain over time. Think of a shared document that many people are editing at once. If one person accidentally deletes a crucial paragraph, it affects everyone else who relies on that information. The same thing happens in JavaScript. When an object is passed from one function to another, it is passed by reference. This means that multiple functions are all looking at the exact same object in memory. If any of those functions modify the object, the change is visible everywhere. This can lead to a domino effect of errors that are difficult to trace back to their source, making our debugging process a nightmare. This is where the concepts of sealing and immutability become so important. They are tools that JavaScript gives us to control how our data can be changed. By using these tools, we can set clear rules. We can decide if new properties can be added. We can decide if existing properties can be deleted. We can even decide if the values of those properties can be altered at all. These rules are not just for us. They are signals to other developers, and even to our future selves, about how this piece of data is intended to be used, preventing accidental modifications. Understanding how to protect our data structures is not an advanced topic reserved for experts. It is a foundational skill that every developer should learn early on. It helps us build more robust applications from the very beginning. When we are deliberate about how data flows and changes in our programs, we write code that is clearer, safer, and much less prone to sudden, mysterious failures. This proactive approach saves us time and frustration, allowing us to focus on building features instead of constantly fixing what is broken under the surface. It is about being intentional with our code. Imagine you have a cardboard box full of your favorite toys. You want to make sure no one adds new toys to the box or takes any of the existing toys out of it completely, so you decide to tape the box shut. This is what Object.seal does in JavaScript. It seals an object. Once an object is sealed, you cannot add new properties to it. You also cannot delete any of the properties that are already there. The structure of the object becomes fixed. You have essentially locked down the list of properties it contains. However, sealing the box does not mean you cannot play with the toys inside. You can still reach in and change the toys themselves. Maybe you can change the color of a toy car or put a different hat on a doll. In JavaScript terms, this means that while the property names are locked, the values of those properties can still be changed. If you have an object representing a user with properties like name and age, sealing it prevents anyone from adding a location property later. But it does not stop them from changing the value of name from Alice to Bob. Let's look at a simple code example to see this in action. We will create a user object and then seal it. Then we will try to make different kinds of changes. Notice how some changes are allowed, while others are silently ignored or in strict mode will throw an error. This demonstrates the specific type of protection that Object.seal provides. It is not about making the data unchangeable. It is about making the object's shape, its set of keys, unchangeable. This can be very useful for ensuring an object always conforms to a predefined structure. Const user profile =, name, Alex, role, developer, object, seal, user profile, / this change is allowed. User profile.name =, Alexandra, console.log, user profile.name, / Alexandra // this addition is not allowed. User profile.team =, front end, console.log, user profile.team, / undefined / this deletion is not allowed. Delete user profile.role, console.log, user profile.role, / developer. In summary, Object.seal is a useful tool when you want to preserve the structure of an object. It is like an agreement that says, these are all the properties this object will ever have. It prevents structural mutations, which can be a common source of bugs when multiple parts of an application share the same object. Think of it as a medium level of protection. It is stricter than a plain object, but more flexible than a completely frozen one. It secures the container, but not the contents within it. Now, let's talk about a much stronger form of data protection immutability. An object is immutable if its state cannot be modified after it is created. This is the ultimate level of safety. If Object.seal is like taping a box shut, then Object.freeze is like encasing that box in a solid block of ice. Not only can you not add or remove toys, but you also cannot reach in and change the toys that are already there. Everything is frozen in place, exactly as it was when it was first created. This concept is what we call immutability. Object.freeze is JavaScript's built-in tool for achieving this. When you apply Object.freeze to an object, you are making it truly read-only. You cannot add new properties. You cannot delete existing properties. And most importantly, you cannot change the values of any existing properties. Any attempt to modify a frozen object will be silently ignored or will throw a type error in strict mode. This provides a very strong guarantee that the data will remain constant throughout its lifetime in your application, no matter where it is passed. Consider a real-world scenario where this would be critical. Imagine you are working with configuration settings for your application. These settings, such as the database URL or an API key, should absolutely never change while the application is running. If some part of your code accidentally modified the database URL, your entire application could break or connect to the wrong service. By freezing the configuration object, you completely eliminate this risk. The data becomes a reliable, unchangeable constant that you can trust. Const app-config =api URL https://api.example.com timeout 5000 Object.freeze app-config // this change is not allowed. App-config.timeout $100000 console.log app-config.timeout //5000 / this addition is not allowed. App-config.version $v2 console.log app-config.version / undefined / this deletion is not allowed. Delete app-config.api URL console.log app-config.api URL // https://api.example.com. The beauty of immutability is the predictability it brings. When a function receives a frozen object, it knows for certain that the object will not be changed by any other part of the program. This simplifies reasoning about our code. We no longer have to worry about spooky action at a distance, where a change in one place causes unexpected side effects somewhere else entirely. Immutability helps us build systems that are easier to debug, test, and understand, because the data flow is clean and one-directional. So how do we put these ideas into practice? JavaScript gives us several ways to enforce immutability, each with different levels of strength. The simplest one is the const keyword. When you declare a variable with const, you cannot reassign that variable to a new value. However, this is only a surface-level protection. If the const variable holds an object or an array, you can still change the contents of that object or array. The const only protects the variable's assignment, not the value's internal state. It is a good first step, but it is not true immutability. For a stronger guarantee, we use Object.freeze, as we have discussed. It provides what is known as shallow immutability. This means it freezes the properties of the object you pass to it. But if one of those properties is itself another object or an array, that nested object is not automatically frozen. You would need to recursively go through the entire data structure and freeze every object at every level to achieve deep immutability. This is an important detail to remember when working with complex, nested data. It freezes the top layer, but not the layers underneath. When applications become very complex, managing immutability manually can be tedious. This is where specialized libraries like Immutable.js come in. A library like this provides a collection of persistent immutable data structures, such as list and map. When you change data in an immutable structure, the library does not modify the original data. Instead, it efficiently creates a new version of the data structure with your change applied. This makes working with immutable data much easier and more performant, especially in large-scale applications, such as those built with frameworks like React. In the end, understanding these tools is about choosing the right level of protection for the right situation. For simple constants, const is often enough. For important configuration objects, Object.seal or Object.freeze provide excellent protection against accidental changes. And for complex application state, a dedicated library can be a lifesaver. As a beginner, starting with these concepts will help you write code that is less buggy, easier to reason about, and more professional. Protecting your data is not a chore. It is a fundamental practice for building reliable and maintainable software.